This is TechSNAP, episode 377. Hi, everyone, and welcome to TechSNAP, Jupiter Broadcasting's weekly systems network and administration podcast. We recorded this episode on July 31st, 2018. It's brought to you by our three great sponsors, iXsystems, Ting, and DigitalOcean. Tell you more about them in a bit. My name is Chris, and joining me every single week is my co-presenter, the teacher, the admin, and the engineer is Mr. Payne, Mr. Wes Payne. Hello, Wes.
Hello, Chris.
Hello, Wes. Why don't we start out with a great warm-up story this week in what might amount to one of the most simple and yet somewhat baffling forms of social engineering.
Hackers from China have taken to sending CDs full of malware to state officials. Yeah, that's right. It is 2 decades ago. Surprisingly, it's happening in just the way that you might think. The trick is pretty simple. A package arrives with a Chinese postmark containing a rambling message and a small CD. The CD, in turn, contains a set of Word files that include script-based malware. The scripts are then run when the victim, for some reason, accesses the files on these CDs and then presumably results in a compromised system. The initial analysis of the CD's contents indicate they contain Mandarin language Microsoft Word .doc files, some of which include malicious Visual Basic scripts. Yes, that's right, Visual Basic. It may not be infecting a computer near you, but it's infecting a computer somewhere.
Well, this is just about as old school as it gets. So you've got CDs, actual CD-ROMs with Word docs on them, with macros on them that are actually executing the malicious payload. And this works? This actually works?
Well, so far, state archives, the state historical societies, and the State Department of Cultural Affairs have all received letters addressed specifically to them, so this is somewhat targeted. However, it's not clear if any one of these agencies was actually tricked into inserting the CD into a government computer. I mean, let's hope not. Hopefully there's been basic training, like, don't just take weird storage media that you find or is mailed to you and then put it in your valuable computers. That's insane.
Well, let's race forward again, back to the present, and talk about what has amounted to a gold rush around these generic TLDs. And we're now seeing a steady flow of them that just didn't quite work out. And sometimes you got to pull the plug.
Yeah, surely, Chris, you remember when these started rolling out and every company, every organization, anyone with enough cash to pony up wanted their own generic top-level domains, right? I mean, we could imagine a .Jupiter.
Heck yeah.
Well, so far, turns out a lot of those were just bad ideas. Last week, ICANN removed the documentation for .Xperia. Yeah, that's right, .Xperia.
Oh, from Sony, like the Sony Xperias.
Their smartphone brand.
Yeah,
exactly.
Sure. I'm sure that went fine.
It's interesting. It's not, in the ages of internet past, that just wasn't something that we saw. .org isn't going anywhere.
Right. .edu is going to be here for the rest of my life as far as I'm concerned.
You can also think of it as maybe just an immense waste of money. A generic top-level domain costs about $185,000 to apply for, and that's assuming that no one challenges you or objects to your application.
We should do a Kickstarter for .Jupiter.
It's
probably already taken. NASA would probably challenge it. Never mind. I retract my idea.
Further research is needed.
Yeah, we'll come up with something else.
And, I mean, at that price, maybe you can argue that it's a good method of ensuring that applicants are actually serious about running a top-level domain. $185,000 isn't a crazy amount for a corporation, but it's not nothing. It's
right.
It's a line item that shows up.
Yeah, that's something to make you think.
Unfortunately, it clearly doesn't seem to stop TLDs from being short-lived or just given up on. This isn't even the first time it's happened. Since being tracked, we've seen .iwc, .sapo, .mio, .boots, .htc, also a smartphone brand, .chloe, .pampered chef, .montblanc, .mcd, and .mcdonald's. They've all been revoked and are no longer actual TLDs.
.mcdonald's. You can see in all of those instances, it sounds like a marketing budget purchase.
Yeah, right.
And they just didn't have the infrastructure behind it then to manage it.
And it is really just for show. In many cases, it doesn't add a whole lot of new functionality. It's not like it's a new sort of subforum or corner of the internet that people besides them will actually use. So I can see how, you got bored of it or you brought in a new marketing department and they're just not interested in paying for all the infrastructure that you need to keep that running.
I would imagine we're going to see a steady stream of this for a while, and probably for quite a while as long as they can keep doing this. It does make you wonder, though, about the permanence of URLs and links. It's something that we struggle with a lot here at Jupiter Broadcasting because we have shows now that have been around for so long that they're linking to posts and pages that just simply no longer exist, even on large publications like the New York Times and TechCrunch. So the ephemeral nature of these links and URLs is already something that concerns me quite a bit. And now we've just sort of added a layer of lacquer and marketing shenanigans on top of what I think is already a pretty bad problem. And for something a little different, let's talk about some extensive research recently by Sophos that has uncovered a trove of new information on the notorious SamSam ransomware, revealing that it has affected far more victims than we previously thought and raised vastly more in ransomware demands, almost $6 million.
Now, if you don't recall, SamSam is a little different than your run-of-the-mill ransomware, mostly because it's used in stealthy, targeted attacks.
Which is probably why we didn't have the full scope before.
Yep, exactly, right? So most ransomware is spread just in large, noisy, untargeted spam campaigns, basically looking for just, whoever is silly enough or uninformed or just accidentally clicks on or is vulnerable to their attack. And then, there you are, ransomware. Your files are encrypted. You can't get to them and pay up or hope you have backups.
Yeah, well, we have seen a lot of that.
The model with SamSam is quite different. It's really only used in targeted attacks. So someone has to have broken into a victim's network and then usually lies in wait for a while before manually running the malware. The attacks are then tailored to cause maximum damage and ransom demands that are measured in the tens of thousands of dollars, if not more. Compare that to, a lot of common ransomware demands that hit your average day home user, which is, usually something in a several $100 range. Adding to the difficulty of understanding SamSam, it's been around since December 2015, but there's only been, relatively few attacks and often with very few details.
And to add to that, if they wait a while before the malware gets activated, it can be hard to tie it to a specific breach event, and that can make reporting and correlating pretty difficult.
This new information adds some insights into just the nature of how SamSam is spread and what makes it unique. Just adding on to, making it difficult to follow is that it's not really tied to one particular class of vulnerability. So unlike something like WannaCry, it doesn't matter if you have a specific patch for it in many cases. It's actually just deployed to computers on the victim's network in the same way as you might install regular software applications. So they take advantages of weak passwords, poor privilege separation, or admins with too much access so that they can elevate themselves through, all sorts of different myriad ways to gain network access once you already have a foothold. And once there, they have an easy platform to run their malware.
Another bit of new information is that until now, it was widely speculated that SamSam was attacking mostly healthcare and government and the education sectors. But now the new research reveals that that's not really the case. It's been much wider.
Yeah, it really has. You might remember the city of Atlanta was recently attacked. That was the most recent time we saw SamSam, and that got a lot of media attention. However, after doing a little more research, Sophos has concluded, and I'm sure talking behind the scenes with some private firms, that actually the private sector has borne the brunt of SamSam attacks. It's just that they've been more reluctant to come forward.
Of course.
I mean, in many cases, they may not be obligated to, and so why would you?
Yeah, and obviously some of them will have backups, and in that case, it's like, oh man, this happened. Well, we're not paying that. Restore the backups. And then, of course, they're not going to say anything.
Yeah, it's interesting. I mean, there's even whole classes now of ransomware insurance where third-party firms are hired and set up to take liability and then step in and try to mitigate things.
And you got to figure the most common thing if people do get bit with ransomware is simply, well, we'll just pay it and get our data back.
We'll just pay, right? Yeah. Mm-hmm. I mean, business operations are down. You just want to get back up to steam.
In a lot of ways, the ransom isn't always that much more than paying a highly trained, highly expensive emergency consultant to come in and help out. So, it might be more expensive, but not much more. And so why not just pay and get your data back, and then you don't have to tell anybody anything.
Exactly.
But, the reality is it's still spreading. Sophos tracks this, and from 2016 to 2018, there is a clear trend line where it is making more and more and more money. So it's obviously still spreading.
In many cases, they've seen it spread first by RDP. Yeah, that's right, your favorite, the remote desktop protocol. So people have weak passwords set or unpatched systems from ages ago. Once it's in, though, it doesn't have to take advantage of any particular vulnerability. It doesn't have worm-like or virus capabilities either. It doesn't spread by itself. It actually just relies on a specific human attacker who's controlling and motivating this. And that's another aspect that makes SamSam so targeted, because once they've gained access, the SamSam operator uses a variety of tools, right? Any of the breaches that they start scanning for once they're in. And that's part of the reason to sit there, right? You can get access to a number of different networks, start doing some reconnaissance, understand how vulnerable their systems are, how widespread those vulnerabilities are, and then assess which targets are highest up on your priority list. From there, you manually spread the malware to a number of machines on the network. And once you're ready, they're all triggered centrally and start within seconds of each other. They all go out, they start notifying users, they start encrypting and making their demands.
For a deeper dive on SamSam and RDP hijacking, check out techsnap.systems/352. We covered that in some detail in that episode. There's much more to come, but before we move on, let's thank Ting. TechSNAP.ting.com. Ting is smarter than unlimited. If you use less, you pay less for your mobile plan. The average Ting bill is just $23 per month per phone. And it's simple because you just pay for what you use, however much you talk, text, and data you use. $6 for the line, and then it's your usage on top of that. And Ting has nationwide coverage, GSM and CDMA, but my favorite aspect, no quote-unquote service agreements or contracts, any termination, things like that. You can turn off your Ting service when you're done with it, and you can sign up when you need a new device. I just recently added a device for the road, and it was just a matter of grabbing the SIM card I had, $9 from the Ting store, popping it in the device. And if you go to techsnap.ting.com, you'll get $25 in credit if you grab one of their SIMs. You could probably get by for more than a month and just have a little backup data when you need it in a tablet. They have all of the great devices, the ones you've heard of and the ones you never have too, that maybe you should consider. techsnap.ting.com. And for a limited time, if you want to buy an iPhone 10 outright from Ting, so you own it, they'll give you $300 in Ting credit. How about that? That's amazing. If $25 will pay for more than your first month, I don't even know. You got to do the math on that one. techsnap.ting.com. Also, a tremendous thank you to DigitalOcean, do.co/snap. Go there to sign up for a $100 credit and learn more about a platform that not only powers a ton of our infrastructure, but the one I use to learn about open source projects and try things out and work with our community to put things in production. And you can see what I'm talking about when you go to do.co/snap. Industry-leading price to performance, predictable costs. My favorite system gives you 4 gigs of RAM, 80 gigabytes of enterprise-grade SSD, 2 CPUs, 3 terabytes of transfer, and a partridge in a pear tree, all for 3 cents an hour. do.co/snap. They also have their flexible droplets where you can mix and match resources. They have their super high-performance CPU and hundreds of gigs of RAM. But whatever you get, even if it's a $5 a month droplet, you'll get those enterprise-grade SSDs. That industry-leading dashboard, that simple, well-documented, easy-to-implement API, and much, much more. do.co/snap. Give it a go. See what I've been talking about. Build your next project there, create a backup website there, or maybe put the next big thing into production. do.co/snap. And let's take a moment and say thank you to iXsystems. iXsystems.com/TechSNAP. That's where you go to learn more about them and you support the show. They'll build solutions around open source. They are so deep into the community that gives them access to really understanding how things are built, how they work, the technology behind what powers some of our most important devices in our enterprise. But whatever your need is, some compute, some web servers, something to store your most important data, iXsystems can white glove build a custom solution just for you based on your needs, support it from beginning to end, and make sure it's optimized for the work. That's what iX brings to the table. Their deep experience in open source, their connections to the industry because they've been around since before the dot-com boom, and the experience of working in this field for that amount of time has given them a unique perspective and a unique ability to build solutions that nobody else can touch. That's why they're the only hardware solutions provider that we recommend. iXsystems.com/TechSNAP. Managing your systems when they're under load can be a big challenge. Getting insights into what's causing that load in those critical moments can be an extreme challenge. So Wes is going to tell us about a couple of tools in development that may help improve those insights, and it all begins in a data center at Facebook.
Facebook obviously operates just an insane number of servers. I mean, it takes a lot to bring you all those memes you just don't care about.
That's so true.
And they've been doing this now for a long time. So as their infrastructure scaled, as they've grown, as they've brought on new products and businesses that they've incorporated within the Facebook structure, they find themselves running on all sorts of machines and networks that span multiple generations. And a side effect of that is that they're running very similar code and applications across different configured machines, right? So you may have one system that runs really well, and then you put it on a system that's a couple years older or configured slightly differently,
Sure.
and suddenly it's not so healthy.
That happens. That really does happen a lot.
In this case, they're having particular trouble with out-of-memory issues. So it'll be running fine on one machine and hitting all kinds of memory problems on another.
You know what? That's exactly what I was thinking when I made that statement. Is it's often a memory issue, or it's an I/O subsystem that's much slower on a different generation.
Yeah, exactly. Now, Facebook runs Linux as their host operating system for just about all of those servers. And as they put it, the traditional Linux out-of-memory killer works fine in some cases, but it often kicks in too late, resulting in a system entering what's known as a live lock state for what can be an indeterminate period. Now, Chris, I'm sure you're familiar with this from a desktop environment. Maybe you're running a few too many Electron apps, you let Chrome just get a little too hungry, and suddenly, well, it's not technically a deadlock because your computer's still doing things, but either it's just stalled on memory, it's sending a bunch of data back and forth between swap, your mouse sort of stutters across the screen, and no real work happens.
Oh man, that's when I started to get really frustrated with my system.
Well, never fear. Facebook has developed OOMD, a faster, more reliable solution to common out-of-memory situations. They've designed it around two key features: pre-out-of-memory hooks and a custom plugin system. The hooks offer visibility into an out-of-memory situation before the workload is threatened, so you can start to understand when your system is under pressure, get some snapshots, understand just what's happening. The plugin system allows you to specify custom policies that can handle each workload running on a host. So you don't just have to rely on the kernel, hoping that it picks a good process to shoot in the head. You can actually use this plugin system to go make sure that things start or restart or are killed in an orderly fashion. After trying it out for a while, they've found that OOMD can respond faster, is less rigid, and is more reliable than the traditional Linux kernel out-of-memory killer. In practice, they've seen 30-minute live locks completely disappear. And if you can imagine yourself the frustrated sysadmin with a live lock system that's important for real production workloads, you can barely get an SSH terminal and you just have to wait for the better part of a half hour before you can do anything?
Have been there.
Now, one reason this can be a big problem is the policy of memory over committal, where more memory is allocated for processes than the actual total available system memory. And it's a common technique for increasing memory utilization because often processes will grab memory but not really use all of it. And as long as they're not fully utilizing the memory they've requested, it'll be fine. Unfortunately, that assumption is not always true. One problem with the existing system is that the kernel's out-of-memory killer's primary responsibility is to protect the kernel. And I mean, rightly so. You need the kernel to keep doing anything. However, it accomplishes that by killing some processes without heed to the importance of a given workload. So whenever the out-of-memory killer engages, there's a significant risk that the applications that you actually care about, Kafka or your Redis cluster or whatever it might be, those will be the things that are killed.
Okay, I'm tracking so far, but one thing I haven't heard you say is if this is a user space thing or a kernel space thing, and from what you've said so far, I'm starting to get the impression this is all done in the user space.
So there may be some changes to appear in an upstream kernel near you sometime in the future, but by and large, this is a user space daemon. And as a result, OOMD is often able to take corrective action in user space before the system-wide out-of-memory killer is actually engaged. And this is exactly where that flexible plugin system comes into play. You can have it triggered to execute custom code that you define. So besides the default SIG kill that's sent, just to whatever applications it happens to pick, developers can also customize their plugin with alternate strategies, such as you might just send a back off message somewhere upstream to say whoa, I need some time to process all the requests that you just sent me. Or you might just go all right, everything, dump all your logs, sync the disks, and then we can start killing things.
So how does it know what processes to kill?
Great question. they use what's known as a kill list, which is an ordered list of known offenders, aka processes or services that ought to be the first to kill in the event of an out-of-memory situation. The currently supported criteria for known offenders are 1, how much memory pressure is that target generating?
Sure.
And 2, how much total memory is the target consuming? Now, those both make sense.
Yep.
As an example, if you have a workload that creates an auxiliary service that just holds onto a bunch of memory, that makes a big in-memory cache for certain hot objects, you can configure your kill list to kill the cache first, provided the cache is above a certain size. So if your cache is getting too big, you're under a whole bunch of pressure, kill that first. Yes, your service will be slow. You won't have that cache for a while as it warms back up, but hopefully then the system can recover without having to go through a whole live lock situation.
One of the things I noticed when doing some research about this is they're using C groups in a new way I hadn't really thought of before.
Yeah, C groups are actually used a whole bunch internally at Facebook, taking advantages of systemd's deep integration with C groups and C groups' ability to partition and control things so that you can actually say, here's my administrative tool set, keep that under these conditions, here's my actual application workload, here's maybe some monitoring stuff, and have them all run separately. OOMD makes use of C group version 2, sophisticated accounting mechanisms to ensure that each workload is behaving appropriately. As an example, C Group 2 reports accurate resource consumption for each workload as well as process metadata. Now, in addition to C groups, Facebook's also using a new kernel metric they're calling pressure stall information, or PSI. Now, this is currently pending upstream integration, and it was developed in-house at Facebook, but is pretty crucial to how OOMD does its job. PSI tracks 3 major system resources: CPU, memory, and I/O, and it provides a canonical view into how the usage of those resources changes over time. So it provides quantifiable measurements of overall workload performance by reporting lost wall time due to resource shortages. To put that another way, PSI aggregates and reports the overall wall clock time in which the tasks in a system or a C group wait for contended hardware resources. As an example, the first use case they're using is in avoiding live locks. Usually this happens because the out-of-memory killer is triggered by a reclaim not being able to free pages. But with all the fast flash devices that we're using these days, there's almost always some clean cache to reclaim. So the out-of-memory killer doesn't often actually kick in, even when tasks spend 90% of their time thrashing the cache pages or just waiting around. There's really no situation where this actually makes sense on modern systems. That's where OOMD can take advantage of these new metrics.
I'd be fascinated to see this go upstream in the Linux kernel down the road, so you can just do this out of the box. But I guess in the meantime, the question I have around this is, how is PSI's CPU component different than really just, say, looking at the load average of a box?
That's a good question. And before, Facebook was using kind of a heuristic integrated set of different VM stats they were pulling from /proc, and it just didn't work very well. In particular, the load average is reported as a raw number of active tasks. You need to know how many CPUs are in the system, how many CPUs the workload is allowed to use, and then think about what the proportion between the load and the number of CPUs actually means. In contrast, PSI reports the percentage of wall clock time in which tasks are waiting for a CPU to run on. It doesn't matter how many CPUs are present or usable. The number always tells the quality of life of tasks in the system or in a particular C group. So if you've limited this C group to a certain subset of processes, you don't have to think about that. You'll just know this is an accurate one number I can look at for the health of the CPU pressure for that C group. Also, the load average is kind of coarse, right? The shortest averaging window is 1 minute, which there's a lot of things that can happen in 1 minute on a modern server. And to make that even worse, it's sampled in 5-second intervals and then averaged to give you that 1 minute average. PSI's shortest window is 10 seconds. It also exports the cumulative stall times in microseconds for synchronously recorded events, meaning that you can actually go to try to see some fluctuations for things that might get averaged out or are too small for that shortest sampling interval. You can still see if really small stalls are suddenly adding on to your total stall time. And I think something you've probably seen in your time as an admin, on Linux, the load average, mostly for historical reasons, includes all uninterruptible tasks. So it does give a broader sense of how busy the system is, but on the flip side, it doesn't really distinguish whether tasks are likely to contend over the CPU or I/O. And depending on which one of those it is, you might have to take very different interventions from the admin perspective. Here, PSI reports independent metrics for the CPU versus I/O weight, and Therefore, you can actually go tell and say, okay, is this too busy for the CPUs? Or do I just have some really slow attached I.O. and I need to go troubleshoot what's taking so long?
Okay, I got to admit, that does sound pretty useful. Is there any way for me to play with this right now?
Well, it hasn't been upstreamed yet, but Facebook has a maintained patch that you can go pull or a Git repo version of the kernel with the patch applied from head. So go pull that down, go compile it yourself. You will have to do a little compiling. You'll also have to enable config_psi, which will create a /proc/pressure directory with 3 files, CPU, memory, and I/O. And if you're using version 2 of cgroups, the cgroups will also have CPU.pressure, memory.pressure, and IO.pressure files beneath their hierarchies as well. So from there, you can start scraping them, maybe go submit some patches to some of your favorite monitoring tools to go add those into the graphical displays, and check out our show notes. You can go find some more sources, some more details about just how to interpret all of these new numbers.
Thanks for sending us your feedback at techsnap.systems/contact, your war stories, your question, and much, much more. In fact, just a note, we're still collecting your backup advice, too, from the last couple of weeks. Tyler wrote in this week with a recent story about getting some work. He says, hey, Chris and Wes, it's been a little while since TechSNAP was on the topic of finding a job in open source, but I wanted to share my story, and thanks for the advice that was given a while back. After finding Jupiter Broadcasting shows a little over 3 years ago, I started my journey with Linux and open source software. It wasn't too far into my endeavor that I came to the conclusion I wanted to work with Linux and open source technologies as a full-time job. I had a passion for managing my own servers, with spinning up open source solutions to make my life and my friends and family's lives a little bit easier. As a recent college graduate, I was working as a technical support for an alarm security manufacturer in southwest Missouri. During any free time I had, I would study for LPIC and practice everything at Linux Academy or on a DigitalOcean droplet, knowing that I didn't have any previous professional experience as a sysadmin. I took good advice from TechSNAP, and I started working on a website to blog about all of the different open source projects that I was working on. My hope in doing this was not only to display my level of knowledge and attention to detail, but to show that this wasn't going to be a fleeting hobby. It was important to show that a future employer could invest in me just as I was trying my best to invest in myself in learning how to best utilize Linux. I knew that it also wouldn't hurt if I got my Linux Essential certification with some help from Linux Academy. A couple of years passed, and thankfully a position opened up at my current employer looking for a system administrator. I was also pleasantly surprised that our other major employer in my area, my current employer, utilized far more Linux servers and open source technologies than I had realized. Needless to say, I applied for a position and I got it. Now I'm working mostly with Linux servers every day, and I'm learning a lot currently about what ElasticStack and SaltStack have to do and what they have to offer, among many other things. I just wanted to thank all of those who gave their advice through those episodes, and for the two of you for working on TechSNAP every week. It's made finding a job in open source far more exciting than just finding another job. Tyler. How great is that?
Congratulations, Tyler. That is awesome and just, I think, very inspiring.
Very much so, Tyler. I love hearing those stories. And good on you for buckling down, getting that work done, showing that you were worth somebody that was investing in, and then seizing an opportunity when it came up. We'd love to hear your stories or advice to help those that are looking for an opportunity like Tyler had. techsnap.systems/contact.
Thanks so much for tuning into this week's episode of the TechSNAP program.
And a little birdie tells me that you should probably check your feed soon. There may be another episode not too long coming down the RSS pipes into your podcast catcher of choice. And if you're not subscribed yet, go to techsnap.systems/subscribe for all the ways to get it in your favorite podcast player. We don't discriminate, however you want to play an 8. I know, I was working on something there. I had nothing.
We don't judge. That's the message here. We don't judge, just keep listening.
Just keep listening. Thanks so much for tuning into this week's episode of the TechSNAP program.
We'll see you next week.